Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to take a look at this, a Tektronix 2445 4-channel oscilloscope. It's an old analog one from the 90s or potentially the late 80s. A lovely viewer recently donated this to me, and I was checking it out last night and discovered that it's not working properly. So in this video, I want to try to see if I can get this thing working. And considering I've never worked on any kind of oscilloscopes before, well, we'll find out if I'm actually able to get it working in this video. So without further ado, let's get right to it. Before we get started with the video, I want to make a little announcement. I'm going to be at 3 upcoming vintage computer festivals. The first one is at the end of July in Atlanta, that's VCF Southeast. Then after that, I'm going to be at the VCF West in San Jose. And then after that, I'm going to be at VCF Midwest again, and that is in Chicago. I'll have all the dates on screen here because I don't remember them off the top of my head. But like all the VCFs I go to, if you want to come meet me in person, well, go find me at those shows. That's it for the announcements. Let's get back to the video. Let's take a quick look at the 2445. So this is a 4-channel oscilloscope. It's got 2 main channels here, which have full control with the voltage per division settings and different coupling. And then there are 2 additional channels right here, which are much simpler channels. Mainly these are designed for triggering, and this is the triggering section. These can be used to draw traces on the screen though, but the voltage per division can either be, I think, 0.5 or 0.1. So you have a lot less flexibility. But like I said, these are still fully functional. It's just they're less capable than these. Of course, this is an analog scope because it's got the CRT here. It can display up to 4 traces at once. And if we power this thing on, it does mostly work. We can have 4 traces here all at one time. All 4 are enabled. Of course, you could do math functions and stuff like that. Being analog, this thing has instant response time, unlike digital scopes, which can be laggy and you can miss stuff, which is really good for seeing little jitter or little spurious signals that might happen. On the other hand, this thing's not a digital storage scope, so you cannot freeze the waveform. If the waveform going into it just stops coming into it, like we switched to the normal trigger mode there, instead of you seeing the waveform without it triggering any longer, it just goes black. I hooked up my little Unity signal generator to the scope. I just have it plugged directly into one of these channels right here. I'll talk about what's wrong with this scope in a second, but I just wanted to kind of show off one of the other neat features about it. So currently we have a sine wave going into here. I think it's 100 kilohertz, and with the trigger set, there we go. It's triggering properly, and you see we can move this around nice and smoothly. Everything works really well. Now with the signal going into this, if I pull the knob out here, there we go. We have that dual trace thing. We can adjust the position up or down of this zoomed in part of the trace, and we can use this knob here to like move through the other waveform. You can see there it's highlighting which part we're looking at, and I can zoom in and out like that, and we can get a close-up look at the waveform. That's a pretty cool feature, and personally I haven't used a lot of analog scopes before, and I've never run into an analog scope that could do this. But then again, I really don't have a lot of experience with analog scopes. This scope also has some cursors capability, so you could do a delta T cursor here, so you can move these around to figure out the exact waveform duration to do a little bit of math calculation that would allow you to calculate exactly the frequency of the waveform you're looking at. It also has another set of cursors for voltage to allow you to look at the peak to peak. And there we go, we're at 1 volt peak to peak, which is exactly what I have the frequency generator set to as well. But let's talk about where the fault is with this oscilloscope. I'm going to plug the signal generator into the first channel here, and I currently have the volts per division set for 500 millivolts, which is exactly the same as it was set to on channel 3 here. So we're sending the same exact signal into this at 500 millivolts per division, and notice the signal we're seeing there, well, it's not looking super good. It's a lot of the amplitude is lost, and in fact, it's not even triggering. Let's see if I can get the triggering to even work. I can't. I think there's just not enough signal there. So if I zoom in, we're at 50 millivolts per division, which doesn't make sense because this signal coming into here is far greater than what we would be seeing here. And let's see if I can get this thing to trigger. Up, there we go. It is actually triggering. Okay, so we are seeing the waveform, and it is a sine wave, and it looks, well, okay, except for the fact that there's a lot of attenuation happening inside the scope. I know it's not my signal generator because it's working fine on these 2 channels, but channel 1 here, well, it has this problem, but it actually gets worse. If I go up on here and we switch the waveform to square wave, well, That's not a square wave. That is something that is really, really not working properly. And we are currently AC coupled. If we turn this to DC coupled, well, that doesn't look right either. And if we turn down to 50 ohms, well, okay, it's working at 50 ohms, but that signal does not look right. And if we go back to the 500, which is what we should be on to look at the signal properly, well, it's just not looking correct at all. Now, if we take this and we plug it back into the channel 3 here, we turn that back on, and we switch the triggering to channel 3. Well, there it is. We'll turn off channel 1 there. There is the nice square wave that we're sending from the signal generator, and it is working without problem. We can go over to channel 4 here as well and switch the triggering to channel 4, and there it is. That's looking good as well. So these two inputs appear to work perfectly. I've sent a whole bunch of different types of inputs into them, and you get a really nice clear signal. But channel 1, on the other hand, if we go back to channel 1 here, well, it has this problem here where the attenuation is way too strong, and then it's also, for whatever reason, softening that waveform far, far too much. Now, there is a bandwidth limit switch right here, so it's turned on there, turned off there, so that puts a 20 megahertz filter on there. But remember, the signal we're sending right now is it's 100 kilohertz, not 1 kilohertz, it's 100 kilohertz. Let's try 1 kilohertz, and let's look at how that looks. Okay, it looks like 1 kilohertz is actually working okay. So I had to reduce this. So we're at 500 millivolts per division. It's still too much attenuation. Let's see if I can get this to trigger. It's very, very touchy, but there it is. So we should be seeing the waveform going all the way between there and there. That would be 2 full divisions, and it's not quite there. So it seems like on input 1, we have a lot of roll-off where even 100 kilohertz was being filtered, and let's change this to 1 megahertz just for fun. And there's 1 megahertz, basically doesn't even show up at all. So we'll go back to 1 kilohertz. So there we go. We are getting 500 millivolts total peak to peak when the signal generator is actually outputting currently 1 volt peak to peak. But if we switch this over to DC coupled like it is now, we're still at the exact same amplitude. And there it is again. So it seems like on channel 1, basically the 50 ohm termination is maybe enabled all the time. I'm not exactly sure, but there's also some serious attenuation happening on the front end that's rolling off the frequencies. Or let's go back to 100 kilohertz, which is still nothing. And look at that, we had so much loss there. Let's see if I can get this to trigger. It is triggered right now, but obviously we went from the 500 millivolts peak to peak to, let's actually see what we're actually getting right now. We are getting 236 millivolts. So very, very little. All right, let's switch over to input number 2 here, and let's take a look at how this one is behaving. What are we getting here? We're not getting any triggering. Okay, so here we are, input number 2. This is looking a lot better. Remember, on input number 1, we had that triangular kind of sawtooth waveform, and we're still at 100 kilohertz on the generator, and yet we're actually getting something that looks somewhat decent. Let's take a look at what the peak to peak is that we're getting. Oh, there we go, move this one down, move this one up. We're getting what it thinks is 5.8 volts on this input. So again, there's something very wrong with the attenuation. This is not 5.8 volts. I'm only sending 1 volt peak to peak out of here, and yet the scope thinks that it's at 5.8. Now, in case you think that this thing is set for like 10x mode, like for the probes that were 10x, that's not the case. Tektronix scopes, including this one, auto-select between 1x, if you just plug a normal BNC in like this, and 10x when you plug a Tektronix probe. There's an extra little pin that touches this ring right here and is able to tell that you have a 10x probe connected and will automatically redo all the calculations, and this would change from 2 volts per division to 200 millivolts per division by just plugging in the probe. So again, something is wrong, but in a different way with the attenuation here. It doesn't seem to be rolling off the frequency quite as much, but obviously the voltage is all wrong. Let's turn this up to a higher speed. We're gonna go to 1 megahertz. And there it is at 1 megahertz. So even at the higher frequency, I would say it's not rolling off, like the frequency is not rolling off, just like on inputs 3 and 4. But on the other hand, we still have the problem with the attenuator being set wrong because it's thinking that we have 5.8 volts peak to peak, which is completely wrong. Now we're on AC coupling. DC coupling, unlike the other one, works fine. There's no leakage of the signal coming through here, although let's change the voltage divider way, way down. Okay, 10 millivolts per division, and that line is still really good. Now let's go to AC coupled. Okay, AC coupled, well, we can see right off the bat, this is not working properly. Let's try to get it to trigger here. There it is. Look at that waveform. It's all kind of messed up. So we're getting 0.4 volts peak to peak now on DC coupled. Now it doesn't matter with the coupling, we should still be seeing this signal coming through properly. There's no DC offset in here for filtering, and the waveform itself should still be visible, especially at 1 megahertz like we're looking at here. Now if we change this to 100 kilohertz again, and we change the time base, okay, well there is roll off that's happening because at 100 kilohertz, now we're having this weird triangular signal, and it also is going a lot further up and down. In fact, let's just change this to see how high and low we're going. 1.28 volts peak to peak. That's just completely wrong. Now I noticed the other night when I was playing around with this thing, doing the testing, that a little bit of percussive maintenance on the bottom of the scope changed the way the signal looked actually. Okay, well it's not doing it, but yeah, if I hit under here, well, I was seeing changes there. So that indicates that there's some kind of a physical problem potentially with the oscilloscope, with the relays or solder joint or something that's going on under the scope in this area right here. Let's jump into the service manual and take a look to see if we can see anything that looks like might be the problem with this, or try to figure out what areas of the scope might be faulty, and let's open it up and see if I can get it fixed. So one thing I gotta say that is freaking awesome about Tektronix is take a look at the fact that they just published the service manual for this scope right on their freaking webpage. That is super amazing. They released it on 2016. I would imagine even before they released it, it was available to download on the internet, but we can get it right from the source, which how awesome is that? So this is the first time I've looked at this manual. Right off the bat, this is really surprising to me. First printing January 1983. I assumed that this oscilloscope was from the very late 80s or into the 90s, not the early 80s, not with all those on-screen displays and stuff. So this scope is probably going to be loaded with a whole bunch of like through-hole goodness inside when we open it up. And well, that's kind of cool because that's certainly easier to fix than a bunch of surface mount stuff. But the other thing is this seems kind of cutting edge for, well, for 1983 scope. Kind of blows my mind, to be honest. Something else interesting is take a look at the maximum input voltage. People who are watching the faults this thing had might have assumed that maybe someone had like put too much voltage into the input stage on this thing and damaged it. I don't think that's the case, because take a look at this. This thing supports up to 400 volts on those inputs, or in fact 800 at peak to peak at 10 kilohertz or less. That's frankly amazing. I'm pretty sure like these new digital scopes can't take anything like this on the front end. Modern scopes rely on the fact that you're going to be using 10x probes or even 100x probes to divide that voltage down by 10 to 1 or 100 to 1 so that the input stages, which probably can't take more than like 30 volts or 40 volts or something like that, don't get damaged. But this thing on the other hand, well, yeah, obviously has a very robust front end. So page 43 here describes the theory of operation of the scope. And let's take a look at this to try to figure out like where the fault may lie. I kind of talked about the fact it seemed like something on the front end. Well, let's take a look at the difference between channels 1 and 2, which have the problem, and 3 and 4, which don't. So 3 and 4 come into the scope, and there's a preamp that's under control of the auxiliary control register, which is part of the digital control of the system, like front panel control and all the CPU and whatever's in this thing. Here's the ROM, RAM, and EPROM. Well, that talks to the control registers that then makes changes on the analog side of the scope. There's going to be like a digital side of the scope and an analog side of the scope. We know that channel 3 and 4 are working completely without any issues at all. So this preamp is fine, and the auxiliary control register for it is working as well. And I didn't really talk about it too much, but I can switch between 0.1 volts per division or 0.5 volts per division on channel 3 and 4, and that's working totally fine. So that's going to be this preamp control that is making those changes. Now channel 2 and 3 have the same preamps right there, which will be controlled from this control register. Now it says CD right here. I'm assuming that is the same thing there that controls those preamps. And I think that part is working as well. But right here are the issues, right? We have the attenuators and the magnetic latch relays. All of this stuff is under control of the control registers as well. But it seems like, at least on the surface, that it's not the control system that's the problem, because as I switch those knobs or alter the controls on the front, I hear all the clicking of what would be those magnetic relays inside. And it all sounds like it's working properly, like it clicks at the correct time when I'm turning the knobs or moving the settings. And it just feels like that control channel is working. But clearly we saw there's something going on with the attenuators or the relays or clicking into the wrong modes or something like that. Let's think about channel 1 for a second. When I enabled the 50 ohm termination resistor internal to the scope and I selected that on the front panel, I would hear the clunk of it selecting that resistor, and yet it didn't seem to actually do anything. So I really think it's something in this area, these 3 boxes right here, the channel 2 attenuator, channel 1 attenuator, and the magnetic latch relay. Some problem is existing in there, or with the connections into that area, something like that. And we can ignore the rest of the scope, like these preamps and the power supply and the ROM, RAM, and all the digital stuff. I think all that is working perfectly. The scope has shown no other weird symptoms. I've had it on for a couple hours and everything was absolutely fine. And then on the second page here, this is talking about the display output. So this is the triggering circuits and the sequencers and all the on-screen display stuff and the sweep stuff. And again, all working perfectly. The CRT presents a perfectly super bright image. The deflection looks perfect. I mean, the text is displayed correctly there. So we can ignore all of this stuff as well. Incidentally as well, this scope has a full suite of onboard diagnostics. When you first turn on the scope, it takes several seconds to start up and it is running through a full suite of diagnostics. And here's a little bit about the tests that are happening. You can actually run them manually, but it happens automatically. And any of these tests fail when you power on the scope. I think it falls into the diagnostic mode where you can select which test you want to run and get error codes and stuff like that. It's passing all of its diagnostic tests without any issue. And I think that's because it doesn't really know what's happening on the front end with the attenuators. It just knows that they're there, but it doesn't necessarily know that they're working properly. And when I look at these different tests that are on here, it's looking for like stuck buttons and errors in the RAM and the main board and stuff like that. It's definitely not looking for anything to do with the front end. And it looks like here we're looking at what is an analog board on this scope. There is probably these two channels here, which I'm going to say are 1 and 2. This will be 1 and 2, and then there's 3 and 4. There's a lot less going on with those because those are the much simpler inputs. All of these large things here, I think, are these large kind of ICs that are hybrid, fancy stuff that makes a lot of the magic possible inside the tech scope. Well, hopefully none of the issues exist within those because I don't know how we would be doing any kind of fixing if that were the case. I'm sure those aren't something you could even hope to buy anymore other than harvest off another one of these scopes. And then here we go. This is the actual diagram, I suppose. I don't know how this works. There it is, channel 1 input. And look right there. Got a bunch of relays and stuff. So those are those electromagnets that control the logic controls, and it switches all this stuff right here. For instance, look at this, times 10. So this will be when you hook up a times 10 probe. It actually is switching, like this relay right here switches these contacts and will bypass, I guess, some kind of a divider or whatever is happening inside of this little box here. It either bypasses, it goes around it, or it goes through it. Right there, that's the same exact thing. 50 ohm resistor, or, well, I don't know what that T is. Oh, it must be, I think it's a thermistor. Oh yeah, that's right. I remember seeing in the manual that the 50 ohm resistor has a temperature sensor and it can actually go over temperature. And when it does, it tries to protect that resistor and it will disable that resistor by switching, you know, this relay contact here. So it takes that out of circuit because of course you could be draining a bunch of current or sinking a bunch of current into that 50 ohm resistor, which can cause it to overheat. So really it feels like the problem has got to exist inside of this area here, and that whatever's making these contacts or switching these contacts here are having issues. Channels 3 and 4 don't have any relays on them at all. Those just are connected to the preamps, but it's 1 and 2 that goes through all this stuff before it heads off over here to these outputs here, and then that goes on to the rest of the scope. Now take a look at this. So here's that front end board again. There's the channels 1 and 2, and look at this block diagram, or this diagram here. Channel 1 attenuator, channel 2 attenuator. Kind of implies that those are maybe separate. Like I was thinking that those possibly just don't have a good connection onto the main board. Is that these metal things right here, A11 and A12? Let's just see. Yeah, A12 and A11. Okay. So it's inside these metal cans. All right, so I think at this point what's left to do is time to disassemble the scope and see if I can figure out what's going on with those two modules. If those are sealed and soldered together, then I think I'm kind of out of luck, but let's cross that bridge when I get to it. Alrighty, I have never taken apart any kind of Tektronix oscilloscope. Now there was information in the manual about it, but I think, oh, there's a screw holding on the power cord. Looks like to get the back cover off, we take out the 4 screws that are on the corners here that hold on these rubber baby buggy bumpers. I can never say that properly. Now, I have heard that this scope, especially being as old as it is, has some reefas in there. And if I do see those, I'm gonna have to try to change those out as well, because of course that would be a smoke show waiting to happen. Now there's a fan in here while it's running, so it would very quickly ventilate and stink up the whole place. There we go. Just pops off. Now looking at the back here, this is the fan. What a cool design. It's like a little cage fan, probably some kind of custom thing. So don't want that to break. Now with this off, I think the blue outside cover comes free. Look at that thing, clean and nice. There it is, there's all that goodness. Check that, oh wow, the bottom of the board. Look at that, whoa. Look at these chips. This is obviously the power switch here. So when you push the power switch, it moves this whole bar around, but whoa, I love it. I freaking love it. Well, anyhow, look right here. Those are the two attenuators that are giving us problems. So I think we'll have to focus on those in a second. And there's a little wire right here as well. I wonder if that could have something to do with it. I can't imagine. I think we're gonna have to take this board out potentially, maybe, not quite sure. Here we have the digital board on this side of the board. You got the ROMs here, but it is really quite clean. Interesting is there's this pin header right here, and these pins are bent as if someone had something connected and then they pulled it off, and they didn't pull it off straight off. They pulled it off at an angle and it bent these. Let's see if I could figure out any date codes on here. I have this board flipped upside down, so it's not super easy to see. 42nd week of 1982, 42nd week of 82 as well. This is the 11th week of 1982. So, okay, this is an old oscilloscope, much older than I thought it was. Must not have been used very much considering how clean and nice this thing is in here. Let's see if I can take these screws out here and remove these covers. And trying to zoom in a little bit, looks like there's a hybrid. I can see a ceramic substrate under there, and it's got components on it, but there's this black plastic thing right there, which is almost certainly those magnetic relays that exist inside of these cages. Maybe what I need to do, there's also this little connection right here as well that is probably for something to do with the control logic. There's one on each side. Maybe what we need to do is power this up while the lid is off, and then I can actually physically hit this area and we can see if that changes anything at all with what we're seeing on the traces on the screen. Now, of course, powering this thing up with the lid removed, I have to be careful because there will be no airflow over all of these custom ICs here. And of course, these things are, going to be fragile and going to be delicate, and I don't want them to overheat. So I need to pay attention to make sure that they do not get too hot. And I want to take a look underneath here because there's almost certainly the power supply section. Of course, the CRT controller and driver and all that stuff is there. So let's see if we see any of those blasted reefas. And this should come free, maybe. There we go. All right, that gives us a view into the power supply board, which is going to be this thing right here. Look at these caps here, really nice, good quality caps. Can I see a brand on those? I cannot. 100 microfarad, 235 volts. I think I read somewhere that these caps have 3 pins because the outside metal is actually shielded. So if you try to replace these, you won't have that shielding anymore unless you can still find caps just like this. I have the camera on manual focus, so hopefully we're able to see, but it looks like down in here, there would be what are reefa caps right here, these white box things. But these are not reefas, so there aren't going to be any issues with those leaking, which is a good thing. I can see a couple of those down there. Although under this cover right here, so this is just a plastic cover, which I think is to protect against high voltage mains because it says 250 volt primary potential under here. I think I see a reefa under there. And we take a couple screws out of the back, and this should lift off that plastic protector. All right, so these are the ones that I identified are not reefas, but they probably would be reefas in other types of power supplies. So they're filter caps. There's one down there, one there, but those are fine. Everything looks super clean in here. That's awesome. But there it is. I think it's in focus. That's the one reefa that I can see. Of course, this is not on the high voltage side. Like this is all the high voltage side, well, the mains potential side. This is going to be something on, well, I don't know, actually. This is probably high voltage DC. There's a rectifier right here. It comes across to that side. That's probably some other little bit of filtering. I don't think that's an X cap, and it's actually not cracked at all. So I'm going to leave that. I would be more worried about these caps down here. These ones here are going to be problematic because, of course, they're connected to mains potential. If they start to become leaky, that's when they let the magic smoke out. And that won't be happening here. All right, so scope is powered up. I have both channels of the signal generator going into it. Both of the channels on the scope are set to, I can't read it, 500 millivolts per division. This thing is outputting 1 volt peak to peak. Of course, you know, both of these aren't looking correct, to be honest, at this point. Let's change the coupling here. DC coupled, AC coupled. Yep. Okay, so it's exhibiting exactly the same issues here. In fact, happening now. Wait, what? How did this happen? How did they get all lined up? Oh, well, look at that. Okay, so yeah, I think it's channel 2. Channel 2 now at 500 millivolts is showing that huge signal that we were seeing before. Let's see if I bump these. Does anything happen? That one has a little bit of an effect there. Look at that. You see that? How this one's changing? We have like an instant where it seems to be working properly, and then it's not. Well, I've been reading through the manual here, and it looks like you can actually remove the attenuator separately from the main board. So I'm gonna follow that procedure to get those out, and we'll take a look at them, because I wanna see is how are those connected to the main board. Perhaps there's some pins or something that slide in, and those are oxidized, and I just need to deoxit those. If not, then with the mount, maybe there's a way to find replacements somehow or service them. So let me follow these instructions and get them out of the scope. All right, making progress. Control panel's out, bezel's off the scope. It's actually good because I can clean under here. I don't think this is actually dirty, the CRT right here, but I can clean that. The 2 input jacks are right here. There are some screws there, and I think it involves taking those out, desoldering some connections. Looking at the instructions, looks like the next step is just to remove these screws right here that hold the attenuators in. With the screws on the front removed, we have to disconnect these multi-pin cables here. There, like that. Next step, it says to remove these screws that hold down the attenuator. There are 2 connections that come out of this. There's this resistor and capacitor that goes into the IC. I have that one disconnected on both. But there's another one that goes to this little, I don't know, it's a thing that's like a screw. And I'm not sure how to disconnect that. So what I'm gonna do is, I think I'm gonna lift up on these. I'm gonna see if they come out of the board. It's definitely moving. I don't know how to get that desoldered. It says on the instructions, simply unsolder the 2 attenuator output leads and compensation capacitor lead. Unplug the attenuator, gently pulling it from the assembly straight up and away from the main board. I mean, it's pretty vague there. So let's see what happens if we can move this thing. I may need to do a little bit of Googling to see if there's a video on maybe how to remove these things. Alrighty, there we go. The attenuators are out. The problem was there were a few more screws on the bottom side that I don't think it mentioned in the manual. You get to them by flipping it over and you go through on the back side, and these things came out. So there's an attenuator bottom, and look at those pins. Nice gold pins. I don't think there's any issue there with bad contact of those particular connections. All right, so with this one attenuator here, I don't even know which is which. To be honest, I should have labeled them. Actually, they're different because the wire here comes out on one side and on the other one comes off on the other side. So they can only go in this way here. So on this one, it seems like this one pin right here is loose. So that could be a problem. This pin is fine, but this one is loose. I think that one is the one that goes to the actual IC. So that's the output pin. And that one is loose. And this will be channel 1 here. So is that a problem? Either way, let's open this up. Let's get these screws out of here and take a look inside of this. Now I'm imagining that what's inside of this is very delicate and very small. And I have no idea if I'm going to be able to repair this. And having never done this before, this could be a fool's errand, that's for sure. So let's carefully get this off here. Oh, wow. These are obviously the relay modules there. Whoa. This little wire seems to be for sensing what type of probe is attached. It goes to the ring on the front there. I think I see how this works. So this block here with these relays, these pins go down into the main board, and it seems like it's loose now somehow. So carefully lift this out. That right there is the front end. So there are gold contacts on there where these relay things touch there. So I'm gonna try to clean that up a little bit with some Deoxit. I'm not gonna spray it directly on there. I am just simply gonna get a little cotton swab and very gently clean those contacts. I can definitely see wear marks on there where it's been rubbing. I'm not sure this is actually gonna do anything at all. Now, one issue is everything is gold plated. So I don't see how, I mean, there's no corrosion. This thing is super clean inside, so I don't really know why this thing's not working. I don't see any issues on here. Everything just looks perfect, basically. There's definitely little wear marks where it's been rubbing, you know, from the little contacts on the relays there. But why is it not working? I don't know. So there's one of the relay modules right there. Very cool. So it's latching as far as I'm aware. It can kind of go into one position or the other. It doesn't need to be powered all the time to do that. And when it latches, it's these contacts here on the bottom that then push down onto the little PCB. So I gotta say, I am at a loss to try to figure out what's wrong here, because this just looks, it looks perfect. It really does. No oxidation, no nothing. I don't see why this is not making good contact still. The only thing I can think of doing is try to like scuff up these little gold pads a little bit where the pins touch. Maybe that'll work. Now I'm gonna try to reattach this loose pin. Not sure what the problem is. That seems better now. But now what I think I'm gonna do is I'm gonna just take these tweezers and very lightly just sort of scuff up the gold contact patch where the little tongs from the relays touch. Just, I'm barely putting any pressure just to kind of mark them up a little bit. There is a little bit of oxidation, I guess. And now I'm just giving a little scratch onto the contacts as well. And I can see these are latched into various positions, which is kind of cool. I rubbed the Deoxit onto those after I scratched it just to kind of clean up anything I left behind. Let's do the same on these. This is Deoxit Fader Lube, so it's not very harsh stuff. And I don't know what else to do other than try to reassemble this thing now. Alrighty, there we go. I think what I might want to do is try to reassemble the scope and you know, at least enough where I can see if this thing is working any differently or any better than it was. Okay, so this thing is roughly assembled. I did put both of them back in. Nothing is screwed together. Front panel is reconnected. I didn't even reconnect the outputs. I'm just gonna see how it works as is right here, make sure everything is clicking normally, and then we'll test out channel 1 there, see if it works any better after that little bit of cleaning that I did. So let's power this on. High voltage just came on. We got clicking of relays. Okay, so it looks like we have no traces. So I'm gonna power this off and I'm gonna reconnect those connections there. Okay, so the one I just serviced, that's what I resoldered. I didn't touch this first one. And this is channel 2, by the way. I said channel 1 earlier, but I was wrong. Channel 2. Alrighty, so 3 and 4 are working, but 1 and 2, we don't get any kind of trace at all. So I know the intensity control is fine because that's 3 and 4 working. But these two are no good anymore. On 5 volts, there's a whole bunch of junk. Oh, wait. Okay, when I push down, suddenly it all appears. Okay, so I think we are having a bad connection issue, and it's pushing down on the tops of the relays here. Oh boy, okay. So there's the signal. I'm operating the scope upside down, so I'm not super good at this. All right, so we are at 500 millivolts per division, and if we move this, we are definitely getting the correct peak to peak on there. So that's actually a huge improvement than what we had. So that's AC coupled, ground, DC coupled, ground, and 50 ohms. But let's go back here. So yeah, that's interesting. That pushing down on the relay definitely makes it work. So that definitely tells us it's a relay problem of some kind. I wonder if this is as much as just ramming something underneath this metal shield that I currently don't have on there, and then that'll make it work. I'm gonna increase this to 10 megahertz. Look at that. Oh, we actually have 10 megahertz showing up on here now. That is a huge improvement. Huge. Actually, just pushing down on the entire module makes it work. Now, the connection from the module, the attenuator module to the main board, that is not the problem. That is a soldered connection on there. I'm pushing down on the relays right now, and that's making it work. So it's not like pushing down, oh, wait a second. Just moving the front input jack kind of makes it work too. Well, let's see what happens if I push down on just the attenuator module. Wait, look at that, makes it work too. Well, it's definitely possible that just screwing this in properly is gonna make it work. Like putting the cover back on and screwing it all down. But again, I just wonder if, before I put this cover on, if I actually like put some paper here, for instance, so when I put that down on there, it will actually really push down on those relays. Okay, so this isn't giving me a lot of confidence, but I am feeling better that scratching up those little pads on the PCB did the trick. We have a 1 megahertz signal, and I think it's the correct peak-to-peak voltage. Actually, you know what? Let me switch over to one of the channels that is unaffected. I don't really trust my little signal generator thing here. It's not a particularly good quality one. There we are on channel 3, and we're actually getting more peak-to-peak voltage than we should be. We're set for 1 volt peak-to-peak, and we're getting about 1.5 volts now. But I gotta say that what we're seeing there on channel 3 is matching what we're seeing on channel 2 when I push on it and we're getting the right signal. So that looks basically exactly the same as the other one. So cool. I think this is actually gonna fix it. Okay, so what am I gonna do? First, we'll turn the scope off. I think the first thing to do is take this module back out. I need to reassemble it to get this cover back on. I have to take it out to do it. I will put some paper underneath here just to kind of squish it all together. And let's see if it all works when I actually have the screws in there. Alrighty, channel 2 is back in with the cover back on, and look, it's connected. And it's actually not all screwed in yet, and yet I don't have to push down on it. Now, I did fold up a piece of paper and put it under the shield, and that seemed to do the trick because, let's see here. Yeah, I'm gonna say this is working. This is freaking fixed. So I'm gonna repeat that on this other one, and then we'll see if this thing is actually working. All right, time for a voiceover about how I service one of these modules. So first you take out the 4 screws around the metal cover. You gently remove it from the top, and that exposes the 4 relay modules on the inside. There are 2 screws you need to remove from the carrier that holds the 4 relays, and then you have to gently pull the carrier out, which takes the 4 relays with it. Now with the PCB substrate exposed, I gently scrape the little gold contacts with some tweezers, and it's very gently. I'm just trying to kind of remove the little indentation that was on there from the relay contacts that were constantly pushing on it. Then I use some Deoxit on a little foam applicator just to clean off any of the debris that I've created from scraping the contacts. I'm also very gentle about this application. I don't want to put too much on because I don't know if this will damage the PCB here. Next, I use those same tweezers to scrape the little tangs that push down onto the PCB. And then again, I use Deoxit on the little applicator to also clean off any scrapings that I created. And now you just have to gently reinsert the relay modules through the holes on the substrate, and then reinstall the 2 screws that hold down the relays. And then in the case of these 2 modules, I inserted some folded paper between the metal cover and the relays just to push them down with a little bit more force. I'm really not sure this actually does anything, but I figured I might as well try. With the module reassembled, you gently reinsert it into the main analog board PCB of the scope, and then you have to resolder the 2 connections. One's for the little compensation capacitor, which has the screw on it, and the other one is the signal input into the hybrid IC. Alrighty, we are ready for testing. The 2 front-end attenuator modules are fully screwed in, resoldered, everything is good. There's paper in there pushing down, front panel's reconnected. So I think, yeah, I think we're good to go. So power on the scope, get the inputs connected here, reposition the camera for easier viewing. Okay, let's turn up the intensity. All right, so we have 1 scope, 2 scopes. We have 2 traces visible. Let's see here. Things are looking good. We're at 500 millivolts per division. I'm at 100 kilohertz here. Let's change the time base. Oh, everyone, this appears to be fixed. It's working. Look at that, everyone. I can't believe it. Honestly, I'm terrible fixing mechanical things like this, and there it is. It's both working. Okay, so let's see. If I hold these together, it does some kind of, let's turn the intensity down, does some kind of synchronization thing, and it takes about 10 seconds. It's just counting up 6, 7, 8, 9, 10. All right. Turn the intensity back up. Okay, so DC, DC, AC coupled, AC coupled. Uh-oh, uh-oh. Oh no, it's not quite there. Oh dear. Okay, so which one is messing up here? It's this one here. Oh, you gotta be kidding me. Oh no. Yeah, still a bad connection in there. Come on, really? So that's AC coupled, but on, no, sorry, DC coupled. AC coupled is good, it's nice and solid. Ground is fine, let's just turn off trace one, we don't need that. It's okay right now. 50 ohm, 50 ohm, let's see, does 50 ohm work on either of these? I can't remember if that is supposed to work. Oh yeah, so 50 ohm is broken on one of them still. So 50 ohm is selected on channel 1 and it's working. Oh, but look, it's flaky as well. Oh man, so there's still connection problems inside there. Like certainly better because AC coupled, which is obviously the one we use the most, is working properly. If we turn on trace 2, there's trace 2. So we have 2 working AC coupled. Oh, look, even that's messing up now. Oh, you gotta be kidding me. Okay, I think what I'm gonna do is I'm gonna loosen the screws that are fastening this down and squish it down before I tighten it, which maybe will push down on the relays more than is getting pushed now. All right, here we go again. So channel 1 is on the top and channel 2 is on the bottom. It's currently DC coupled. So ground, ground, and now we are on AC coupled on both of them. The offset needs to be changed a little bit. Amplitude looks completely fine. And let's switch this to 50 ohm. Okay, that's channel 1 at 50 ohm. 50 ohm overload. Interesting. Okay, so channel 1, 50 ohms is fine. Channel 2, oh look, it's messed up. So AC, DC, oh DC looks okay now. And right away it says overload. So whatever I was doing inside there, clearly I messed it up. So what happens is it detects an overload and then it immediately switches, back to ground. And look at that. So DC looks bad. If I go back and forth, there it is. It looks fine now. So it is still not working properly, unfortunately. At this point, I'm at a loss on how to fix this. I've already taken it apart twice, done all the cleaning that I did for channel 1 as well twice. In fact, I kind of replicated the methodology I used on the first channel, which was the second one I did, when I redid this second channel one, and it didn't really help. Look, it's acting just as bad as it was the first time. Look, there it is, it's completely screwed up, but you just sort of push on it a little bit and it works again. I have tried different coax, by the way. I've like swapped these around and there's absolutely no difference. It's just as flaky with whichever wire. I put a little Deoxit inside that socket as well, and that didn't really fix anything either. And obviously whatever I did on the second cleaning of this module caused it to just immediately overload with the 50 ohms, even though clearly that's not true. Well, at this point, I'm not really sure what else to do. AC coupling is working fine on channel 2 now, but DC coupling seems to have broken altogether. And of course, the 50 ohm mode is completely broken now. It just says overload. I haven't actually looked to see if I could find some of these attenuation modules on the internet. Maybe they're out there cheap, but I have a feeling people are going to charge like $100 or $150 for these things. And who even knows if they work? The ones that are sitting around on shelves could be that they've oxidized in similar ways to these, and they're not going to be any better. Unfortunately, this scope is a nice scope, but it's certainly not a top-of-the-line scope. It's good, but not amazing. So spending a bunch of money on this is probably not something that I really want to do. Okay, I think I'm going to just reassemble this thing, and maybe putting the screws in will make this work a little bit better, or maybe it'll completely break again. Alrighty, it is back together. And actually, the overloading problem with the 50 ohms is fixed. That was because I had that little I don't know, that little 3-pin wire that goes from the attenuator to the main board, I had it reversed. I realized that because when I plugged in the Tektronix probe here, it didn't auto-detect that it was the 10X probe. So I knew that that must be part of that entire overload system as well. So I currently have the 2 probes connected to the test point here. And what's cool about this particular oscilloscope is that that test output there actually changes frequency depending on the horizontal time base. So we're looking at channels 1 and 2. Top trace is channel 1, bottom trace is channel 2. And if we turn on the cursors, we can check the peak-to-peak voltage of the 2 waveforms we're seeing there. We're at 400 millivolts peak-to-peak on channel 2, which is the correct output for this particular test point here. And if we go up to channel 1, it is exactly the same. Excellent. Now we can change the time base here, and it's not changing. We're still getting 400 millivolts there, and let's go down to the other one. Same thing, 400 millivolts. So right now on AC coupling, this thing's working great. Really is working properly now. Now, I don't know the long-term reliability because obviously if you touch these, well, it seems to be pretty stable on the AC mode, but obviously, you know, in a month, it could stop working again. Let's check out DC. So that's channel 1 on DC and channel 2 on DC. So for now, these are actually both working. So we're still getting 400 millivolts there, and we're also getting 400 millivolts on the other channel. So right now, both channels are working, but I can tell you that I definitely witnessed, since I put this thing back together, that channel 2 was still screwing up a little bit and just sort of pushing on this BNC jack here, kind of made it come and go. And there it is. DC coupling is now messed up, and it kind of just comes and goes. And there, like, see, I just sort of pushed on the BNC a little bit, and then it came good. So obviously we're dealing with contact issues inside that attenuator with those relays. Using this scope, if you're going to use it in 2-channel mode, certainly not great, because you need to be able to trust your instruments. And clearly, anytime you're connecting stuff to the second input, you don't really know if what you're seeing is a problem with the attenuator in there or is actually the signal you're looking at or measuring. And that's a real problem. You need to be able to trust your instruments. And unfortunately, channel 2 on this thing, it's just not trustworthy the way it is now, even though, as you can see, it's working at the moment. And with that, we're going to end this video here. I hope you enjoyed my repair of the Tektronix 2445. At least if you have one of these, you can hopefully figure out how to get those attenuators out and try to clean them yourself, and maybe you'll have better luck and both of yours will work, unlike with this unit. It is a little strange to me that this thing had so many issues inside those attenuators, considering how amazingly clean and, well, perfect looking this 1982 scope is. I've worked on some really dirty equipment on the channel before, like that TRS-80 Model 2. Had debris and leaves and stuff inside, and this thing couldn't be further from that when it comes to being such a pristine piece of equipment that is of a similar age. So it is a little bit strange that everything inside that attenuator, even though it's all gold contacts and gold pins, was having so much issues when it comes to those contacts. Well, it still is having issues. If you have thoughts on a better way I can service those modules to make this thing a bit more reliable, definitely let me know in the comment section below. Or if you have an idea of where to get some maybe modules for this thing, well, inexpensively, and ones that actually work, also let me know. But until that time, I'm not going to consider this scope totally fixed because of the unreliability of that second channel. I'll probably put a note on there just to remind me in the future that it's the second channel that's having trouble and that I had to clean channels 1 and 2 to make it work again, and not to trust that thing if I were going to go use it. And you might be asking, why even have an analog scope when I have plenty of digital scopes? There are definitely times when an analog scope is far superior, in my opinion, than a digital scope, and that is for measuring analog sources. If you're measuring like RF coming off of a videotape head, or you're measuring differential amplifiers on a disk drive, you really, really need an analog scope. Well, I guess you don't need to have one, but it's certainly better to use an analog scope. You just are going to get more information and be able to see exactly what's happening with the signals with a scope like this versus an analog scope with that slow refresh. Even if you have a scope that's fast, it just doesn't compare to the capability of this thing when it comes to those types of signals. Anyhow, that's really going to be it. So huge thanks to my patrons. Their names are scrolling up the side of the screen. It honestly makes it totally possible that I can even do this channel now to have all the support of my patrons. So it means so freaking much to me. So thank you very much. If you want to become a patron, you can do so at the link in the description below. You get early access videos, all that good stuff. And don't forget to hit that subscribe button if you haven't already. That also means a lot to me. It really improves the performance of the videos on the channels that have more subscribers. So just hitting that subscribe button makes a big difference. And then I think that's gonna be it. So thanks very much for watching, and I will see you next time. Bye.